Hi, and welcome to this talk about the MDriven architecture. I will go through how a standalone application usually works. And that's important to understand how the architecture is built, because of course this is no magic involved. This is just a lot of components running to give you a very easy end result, the turnkey server. But to get there, we need to understand how we would create a standalone application, how its database connections would work, what the sync server does and why it's important, what the MDriven server brings to the table, and then the turnkey server on top of the MDriven server. The turnkey server then doing web rendering and supporting thin clients. So we'll start with a clean slate and go from there. The most basic application has a SQL database and something in memory. In the MDriven case, it's an echo space. That's just the in-memory representation of the .NET objects. And we have some way of getting things into memory and storing the result back. If you use Visual Studio to create any kind really of program, you use C# for example, you have something in memory like an echo space and you have the SQL database. Traditionally, you can write your own SQL code, your own queries that is, and you can turn that SQL data into in-memory objects, and you can then transform it back into the SQL database. If we look a little more closely on how this would be done using Visual Studio and the MDriven frameworks, we have the same building blocks, the SQL database containing tables with attributes, and we usually store the UML model itself in the SQL database, because then we know that they're always in sync, the table definitions and the UML model. And then inside Visual Studio you have the MDriven designer, that is a UML design surface, and you can do your view models and you can do actions, and everything is available in code. So you generate the SQL database with all the tables and attributes and indexes and stuff like that, and you store your UML model there. And then you also generate stub code. That is basically for every class in your model, you'll have a class in C#. Now, when your executable runs, you'll have the echo space holding the memory representation of what's in the SQL database. Just a subset, of course, but the things that you need to present to the end user. And then you have some link to connect the two, and this is done by the MDriven framework. So that's a basic setup of a standalone application. And it can be like Windows Forms, Windows BPF, or of course you can write your own web server using ASP.NET. But we want to simplify that. So if we move that to the side and expand on this, you have the same building blocks, and we're just going to look at it a little more specific. You have the MDriven designer, and you generate the model and table metadata, that is easy to access indexes of what's in your database, like all the tables in green here. And you have your generated code, that is the stubs. And then you can add your own code. You don't have to, but you can do for high performance things, for example image processing. And you have in the executable, you have again the MDriven framework, and then you have something called persistence mappers. Persistence mappers is where the in-memory object is transformed for storage, that is persistence. And there are several persistence mappers available, but the most common ones are the one for SQL Server and MySQL. Now this is a direct connection then from your executable through the MDriven framework, through the persistence mapper, directly to a SQL Server database. Nothing strange going on here, it's just a normal connection, and the persistence mapper generates SQL queries for reading and writing data. So when you are running your executable, the generate code is running, your own code is running, and they use the echo space to communicate through the persistence mapper with the database. So still a single user really application. But one of the difficult things with having this is what happens if there are multiple users and one of them changes things in the SQL database. How do I get to know that when I have this local executable running? The next step is introducing another type of persistence mapper. So let's move to that one. In this slide, we'll look at the EchoSpace sync server. And it's important to understand why this is, and it was, like I said before, the need for multiple users to be able to see when the SQL database changes in an easy to consume way for you as a developer. So you have the SQL database, and you have several executables. And they can, of course, all communicate directly with the SQL Server. The problem is the classical one, that you have to ask and ask and ask and ask the SQL Server about what's going on, what has changed. You need to reread a lot of data from the SQL database, which lowers performance and is a lot of hassle. So we'll remove that. We don't have direct persistence mapper to the SQL Server. We introduce the sync server. You have the same MDriven frameworks in each of your executable. You have the echo space, and then you have the sync server. And then you have another type of persistence mapper, which doesn't talk SQL. It talks the sync server language. So each client talks to the sync server, and the sync server talks to the SQL database. This basically gives the sync server the ability to spy on the clients. So the sync server knows what each client changes, so it can keep a list of dirty objects. Dirty here means that something has changed in them. And then each client can subscribe, that is poll, the sync server for dirty objects. And if a client is informed that this object is dirty, it is not immediately refetched from the SQL server. It is just marked as out of date. All requests for data, both reading and writing, is just passed through the sync server. The idea of the sync server is to keep track of what each and every client does. Now, let's move on to the MDriven server, which is a step to managing the model. So you have this multiple client application running, and you synchronize the echo spaces so that they're always up to date. But you still have this problem of when I evolve my model, I need to recompile the executable. It would be better if the model could be dynamic. That is, the model could be stored and managed server side, and your client would just get the model. So let's have the same blocks. You have an executable and a SQL database. And now we're introducing the MDriven Server. The purpose of the MDriven Server is to move administration away from Visual Studio and compiling code that needs to be in sync between your executable and the SQL Server database. So we introduce an admin database within the SQL database. And then we have 3 application slots, A0 to A2. We have the same sync servers. Now the sync server are included inside the MDriven server and talk to the app slots. Your executable has the same MDriven framework and the echo space, and the sync server persistence mapper talking to the sync servers inside the MDriven server. Now for the most important part, and the part that you see of the MDriven server, and that is the Iis Engine. The MDriven server is an Iis application running inside the Internet Information Server. And it has this model administration part that can talk to the MDriven designer. So when you press the cloud symbol in the MDriven designer, you're uploading a new model to the MDriven server. The MDriven server then is responsible for evolving the database, that is the database in the app slot A0 to A2, and record what it's been doing in the admin database. The admin database also contains other things like server-side jobs, that is that you can set up jobs that runs periodically on the data in the app slot. And you can send emails, you can assign numbers, you can do all things that you can do with view models and action language and update the database. And because this also goes through the sync servers, your clients will be almost immediately notified and can see the changes without querying the SQL database again. You can also import and export data, and you can use the JSON interface to directly support other types of clients directly from the MDriven server. So in this way, you can capture the business logic for any kind of interface just using the MDriven server. And the MDriven server don't need the Turnkey server to run. It's perfectly fine just to install the MDriven server using the MDriven designer and create any kind of user interface. So now that we have the MDriven server and the SQL database and really any kind of executable that talks to this MDriven, that is basically an object server, and you can upload new models and it can automatically evolve the databases, we are ready to put an web-based interface on this cloud-based database, and that is the Turnkey server. So we'll keep that in mind, what we have, and look at the differences now using the Turnkey server. The Turnkey server contains the MDriven server. That is, they're both running within the Internet Information Server. they're basically two Iis apps running alongside each other. Actually, the MDriven server is running in a subdirectory of the Turnkey server. In the easiest configuration, the Turnkey server contains a SQL Server compact database. And the reason for that is that it should all be able to run within a single Azure application. And even though the MDriven server supports 3 app slots, the Turnkey server only uses 1. It uses an admin for handling, evolving the model, supporting different kind of interfaces, but it only uses app slot 0. The MDriven designer communicates directly with the MDriven server within the Turnkey server. So the Turnkey server wraps both the MDriven server and the SQL Server compact. If you want to, inside the MDriven server, you can point to any other SQL server, either within your local server farm or, for example, on Azure on an Azure SQL Server database. Now we have the same if you compare your executable up to the left with this new here. We call that the model executor. It's the same thing, but it's more generic and it's inside the Turnkey server. But they are the same components. Now, to turn this into something that we can connect to with web browsers, we need to generate a user interface in HTML. We do that by using the Turnkey web renderer, talking directly to the model administration part of the MDriven server. So it retrieves the view models from the uploaded model, and it gets its data through the sync server interface from the database, and it runs many echo spaces. There's an MVC, ASP.NET MVC standard renderer that does the basic rendering. It's like if you look at the web interface, the menu, and if you want to, all the forms, because everything can be rendered in using basic MVC. And now we have something that can render a user interface to any web browser. To make it more appealing to the eye, there's a Bootstrap layout renderer. It takes a view model from the model and turns it into a Bootstrap layout. And this HTML can then be data bound, that is, the data can be inserted into the layout either on the server using MVC, Razor code, or the Turnkey web renderer can output AngularJS commands. And then, if AngularJS is intended target, the MVC page will contain Angular TypeScript code that can talk to the streaming interface of the Turnkey server. So in one scenario, you data bind, you put the data into the forms on the server and send it to the client. In the other scenario, you just send the form with AngularJS binding commands, and then you send the view model class objects to the web client, to the web browser, and you bind it locally using AngularJS. And that gives a much more fine-grained and responsive user interface. But there are good and bad things with both of them. If you have a lot of data that you need to render quickly, the MVC renderer is much faster. If you have detailed data that users should edit, the AngularJS renderer is much better because it provides feedback to the user when editing. So there are different things going on here. And now when we have the streaming interface, you can create any thin client. And there is, for example, the VPS thin client for Windows, which uses the same streaming interface on the Turnkey web server, but doesn't use the MVC renderer, it doesn't use AngularJS, and it doesn't use Bootstrap. It just uses the streaming interface to get to the data and the model. So this wraps up this summary of the Turnkey server. Thank you for listening.